I'm going to skip linear because it's really easy. The next one was the trigonal planar. And so this one is flat on the screen. You can kind of turn it so that you can see it from an angle. That these three atoms are on the same plane. Anyway, and if I look down here, let me see how I like to do that. Look down here, I have this marked. You can kind of quiz yourself by not having those marked and guess. The electron geometry, the sticks, is trigonal planar. And then looking at just the atoms, the white atoms, they are also trigonal planar, so I can have that show up. Okay, so that's the basic shape. What if one of those groups was a lone pair instead? So I'm going to take off an atom, add a lone pair. We still have 3 electron groups. So this lone pair here counts as a group. So there's this single bond and this single bond. So 3 electron groups. The electron geometry is still trigonal planar, but now the molecular geometry is bent, because when we look at molecular geometry, we're only looking at the atoms. So these 3 atoms, that makes a bent geometry. And by the way, I call this bent 120 degrees. They don't have the angle there, because when it's based on the triangle, it's bent 120. Okay, and then, so I'm going to take one of those off. So those are the 2 shapes with the triangle, are to have trigonal planar and then bent 120. Let's go ahead and add, so we'll have 4 groups, and our next basic shape was the tetrahedron. So this is the one where it kind of is a pyramid. It has these 3 down here kind of on the ground, and this one points straight up. So that's our tetrahedron. And since on this one we don't have any lone pairs, we have 4 electron groups, and they all repel each other. The electron geometry is tetrahedral. And if we look at just the atoms, the geometry is tetrahedral. So notice that when there are no lone pairs, the electron and molecular geometry will be the same. Let's turn these off so we can guess next time. Okay, so let's see what it's like with a lone pair. I'm going to take one of those off and add a lone pair, and I'm just going to hold, I like these lone pairs, they look like eyes. It's like they have personalities. Anyway, so now it's kind of got a triangle, a pyramidal shape still, but it's not as tall as a tetrahedron. The electron geometry though is still tetrahedral, because you see these 3 down here. Electron geometry is still tetrahedral. Question is, what do we call what's left? And these names are on your table on your PowerPoint, but these 3 are touching the ground, and this one is kind of raised up a little. So this is a pyramid, a trigonal pyramid. Trigonal because it has a triangle at its base. Okay, let's try another one. Let's take off one of those atoms and add another lone pair. And by the way, this is water. This is how water is. Let me see if I can, maybe I'll do it this way. Yeah, maybe that way. Okay. Anyway, so on water, it has 2 bonding pairs, single bonds, and then it has 2 lone pairs. So 4 electron groups. The electron geometry then, with 4 electron groups, will be tetrahedral. And then when we do the molecular geometry, we're going to just look at what's left, which is these 3 atoms. Those 3 atoms make a bent shape. And that bent shape is 109.5 degrees. That should be on your table on your PowerPoint. Yes, it is on your PowerPoint. Anyway, and then you guys, if I took off an atom and I put another lone pair, what shape would that be? Well, the electrons would be tetrahedral, but the molecular geometry would just be linear, because when you have 2, that's what happens.